Hello everyone. In this lecture I shall discuss the solution of the game for payoff matrix of order 2 cross n. If we recall our previous lectures, in lecture 1 we have seen the saddle point and cases of pair strategy. It is in our lecture 1, right? Saddle point and cases of pair strategy. In lecture 2 we have discussed cases of mixed strategy for 2 cross 2 payoff matrix. In our lecture 3 we have discussed the dominance rule to reduce the M cross n matrix to 2 cross 2 matrix if possible, right? Now there are certain matrices of order 2 cross n or M cross 2, right? And where it is not possible to reduce further, so now in that case we will use the graphical method, right? We use here the graphical method to reduce it to 2 cross 2 payoff. Once we reduce it to 2 cross 2 payoff, then we use here method 2 here, okay? So that means the mixed strategy case direct formula we will apply, okay? So now we will discuss the payoff matrix for order 2 cross n and we use the graphical method in this lecture. So before we have the detailed discussion, let me to introduce myself. Professor Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. So now without much delay, let us now start the discussion of this case. So now let us discuss the working rule for 2 cross n payoff matrix, okay? Suppose you are given a 2 cross n payoff matrix, right? You are given a 2 cross n payoff matrix like this. A11, right? A11, A is having 2 strategy A1, A2, B is having n strategy B1, B2, Bn, and the matrix is A11, A12, A1n, B, A21, A22 up to 2n. It is a matrix of order 2 cross n, right? Now we consider two vertical lines at a unit distance apart. Means what you do in step 2, you take two vertical lines, right? Two vertical lines at a unit distance apart. Right? Let it be my 0 point. Then you mark here A11, A12 like this. Some negative point may be also there, no issue. Then accordingly here suppose A21, A22, okay, A22, likewise A23, likewise you mark it on, right? In a proper scale you mark these points, okay? So consider two vertical lines at a unit distance apart. This is the unit distance apart, okay, representing, let it be my A1, let it be A2, okay? Or if you will take A1, this is A1, or if you are taking this is A2, or you are taking this is A1, then also it's fine, no issue, okay? Then what you have to do, representing A1 and A2 and are marked, and you mark all these AIs on this A1 and A2, okay? Now join, look here B1 here, B1 is the joining of A11 with A21, okay? A11, suppose this is my B1, A11 with A21, this is suppose your B1. Likewise you join all B2, B3, B4, you join everything, okay? B1, B2, B3, etc. You join everything, right? So marked with A is a values on the same convenient scale. Now you join your A1j and A2j, A1j lying on A1 and A2j lying on A2, okay? Representing all the strategies BJs, okay? After you representing this, you just note that if you recall, what is the objective of A? Objective of A is to maximize the minimum profit, okay? So minimum profit row minima, then you maximize it, right? So from this graph you find the lower envelope, right? For your minimum, right? For your minimum you find the lower envelope, right? Bounded by all the lines. Okay, lower envelope bounded by all the lines means suppose this is my lower envelope, right? Lower envelope, then you find the maximum point. This lower envelope means minimum expected payoff. As you know, for A we are finding row minima, then we are going to maximize it. Okay, so you find the lower envelope, you find, okay, lower envelope bounded by all the lines. Then we need the maximin point. So what is this maximin point? So we find this maximin point is the highest point, right? Means it is the highest point of the lower envelope, right? So this is the maximin point, right? Maximin point. Now this maximin point is suppose the intersection of, I say, BR and BS. I say suppose this is the intersection point of BR and BS, right? So find the maximin point. So this maximin point is the highest point of the lower envelope, right? So this is the highest point, means from this lower envelope we find the highest point. So the highest point of the lower envelope. Now if this point, if this point happens to be the intersection of BR and BS, then we have the 2 by 2 payoff matrix is as follows. Okay, so now if this point happens to be the intersection point of BR and BS, then the reduced 2x2 payoff matrix is given by, so you have your matrix is, for A we have A1 and A2, right? For player A1 and A2. Now this B1 is reduced with BR and BS. Okay, rest are dominated by graphical method. So this will be your A1R, A1S, A2R, A2S. Now it is a 2x2 matrix. Once we reach at a 2x2 matrix, then you know what to do, is not it? Then you know what to do. You find by recalling your lecture 2, right? Recalling your lecture 2 here. Recalling lecture 2, what you will have to find? You have to find the value of the game. What is lambda? Your lambda is this plus this, A1R plus A2S minus this and this, A1S plus A2R. Okay, now what is my value of the game? V is my A1R into A2S minus A1S into A2R divided by your lambda. Okay, so after you get the value of the game. So after getting the value of the game, and what is your P1? Your P1 will be this minus this by lambda. P1 will be A2S minus A2R by lambda. And what is your P2? P2 is 1 minus P1. Then what is your Q1? Q1 will be this minus this. Okay, it is, so Q1 will be your A2S minus A1S divided by your lambda. Okay, then accordingly you find your mixed strategy. You find you find the mixed strategy. Your SA will be SA is having only two strategy. SA will be A1 A2 P1 P2, and for your SB you have B1 B2 so on BR so on BS. Okay, then your so on BN, right? So now this is your 0, this is your 0, and up to this is my Q1 and this is my Q2, this is my 0. Okay, accordingly we substitute the value of, and your Q2 will be 1 minus q1. Okay, and you substitute here q1 q2, you substitute here p1 p2, you substitute here. This is the value of the game, and which will conclude, and you get the answer. Okay, so this is the working rule. Now if you solve one example, then your idea will clear. So let us solve one example. So here we given by this, and solve, just write one line, and solve by usual process, and solve by usual process, right? So this is the procedure we conclude here. Now this usual process means this is the usual process we know in view of our lecture 2, right? So now let us solve one example. So coming to the solution, consider you are given this payoff matrix. This is a 2 cross 3 payoff matrix is given. Consider the given payoff matrix. This is 1 3 11 8 5 2. Now we first see whether there is any saddle point. We'll first see here. So what is your row minima here? We'll find the row minima and we mark it star here. So row minima is 1 here, and we find the column maxima. Row minima in this row, the row minima is 2. Then we find the column maxima, and we suppose mark the column maxima by here plus we mark it. So column maxima is this, column maxima is this, column maxima is this. So there is no saddle point, right? As maximin is not equal to minimax, right? Minimax, there is no saddle point. There is no saddle point. Then we see also domination is not possible. Any column cannot dominate the other column, right? Also domination is not possible. So the only idea here is we have to use the graphical method, right? Since it is a 2 cross n matrix, here n is 3, so we use graphical method. Okay, so let us now use the graphical method. So we use the graphical method. So for graphical method, we have our A1 and A2 here, and our B1, B2 and B3 here. So we take two vertical lines at a unit distance apart. Okay, graphical method as follows. Consider two vertical lines representing A1 and A2, right, having unit distance apart. So you see the vertical lines here. So you consider two vertical lines with unit distance apart, right? So here you mark, suppose this is my 0 here. Now we have to mark the on A1 here 1, 3 and 11. So we consider two parallel lines here, vertical lines. This suppose represents my A1 and this represents my A2. Okay, so here the points are 1, 3, 11, 8, 5 and 2. So there is no value towards the negative. So there is no value towards negative. It is my 0 and it is my 0, and I mark the points. In A1 axis it is 1, 3 and 11 here. Okay, suppose I have this is my 1. Okay, proper scale 2, 3, this is my 3, then 4, 5, 6, 7, 8, 9, 10, 11. In proper scale you take. Okay, this is your 11 now. Now on second A2 line we have 2, 5 and 8. So this is my 2 here, this is my 2 here, then this is my 5 here, this is my 5 here, and I have my 8, 6, 7, 4, 5, 6, 7, 8. This is my 4, 5, 6, 7, 8. Suppose this is my 8 here, and 5 is 4, 5. my 5 4 5 5 is my here. Okay, in proper scale we have to take. Okay, you should use the graph paper, you can take the proper scale. Then I join B1 B2 B3. So in my B1 it is here 1 8. So this is my 1 and this is my 8. Okay, this is my 1 and this is my 8. So this is my B1. I join this. I join this in proper scale, you should join. So this is my 8, say. This is my 8, okay. So here this is your B1. This is your B1, right? Then coming to the second point, it is 3 and 5. So coming to, you join 3 and 5 here. Okay, 3 and 5. This is 3 and this is 5. You join 3 and 5. This is your B2. Then you join 11 and 2. 11 and 2 you join here, right? You join 11 and 2, right? 11 and 2 you join. So you join 11 and 2, right? This you join this. Then you find the lower envelope. As we mentioned here, we have to think of the lower envelope, the minimum, then maximum. So we have to take the lower envelope and the highest point of this lower envelope. So now we see the lower envelope here, bounded by all the lines. So now below this line, right, we have below this line, and below this line. So what is the common region here? So the common region will be my this. Okay, so this is my common region. Okay, so this is my common region here, bounded by all the lines. So this is my common. I just shaded this region here. Okay, so now in this region I have to search the highest point. Is it not the highest point, right? So this is the highest point. So this highest point is the intersection of B2 and B3, is not it? So this is the intersection of this point is here maximum point, right? This point is here maximum point now. Okay, here maximum point here, and this maximum point is the intersection of B2 and B3. Is it not the intersection point of B2 B3, right? So your B1, is dominated. Okay, so your B1 is dominated, right? B1 is dominated. So the reduced matrix is, right, we write it like this. So we have, this is the lower envelope and this is the highest point. Clear? So clearly from the graph we write it. Clearly from the graph, the maximum point of the lower envelope, the maximum point of the, or the highest point we write it, the highest point, the highest point of the lower envelope, that is maximum point is the intersection of B2 and B3. Thus the reduced matrix is, the reduced payoff matrix is given by your A1 A2 remain silent. Now your B2 and B3, B1 is dominated, B2 and B3. Okay, so B2 and B3, we have our B2 and B3. So now this B1 is dominated and we have B2 and B3 is my 3 11 5 2. 3 11 5 2. Let it be resemblance to here A11 A12 A21 A22. Now it is a 2 cross 2 payoff matrix. Now we use the formula. For the mixed strategy case we use the formula, right? Clearly let now solving this, on solving let your lambda is equal to this into this plus this minus this plus this, a11 plus a22 minus a21 plus a12. If you solve it, it is 3 plus 2 minus 5 plus 11. Okay, this is here 6 minus 5 minus this is 11 plus 5, 16. Okay, so this is your minus 11. Now what is your value of the game? Now value of the game is V is equal to your a11 into a22 minus a21 into a12 divided by lambda. Okay, so this will be 3 into 2 minus 11 into 5 divided by lambda is my minus 11. So this is equal to my 6 minus 55 by minus 11 minus 49 by 11 is your 49 by 11. 49 by 11. So this is your value of the game. Okay. Next, let the mix strategy. Let the mix strategy. Next, let the mix strategy SA and SB for players A and B respectively are given by SA. So my SA is fixed A1 A2. So here it is my P1 and P2. These strategies are fixed. And my SB is B1, B2, B3. So now coming to your B1. B1 is omitted 0 and it is my Q1, it is my Q2 such that my P1 plus P2 is equal to 1 and Q1 plus Q2 is equal to 1. Now we apply the formula for your P1. So your P1 is equal to this is A11, A12, A21, A22. Here P1 is A22 minus A21 by lambda and P2 is 1 minus P1 and here Q1 is A22 minus A12 by lambda and Q2 is 1 minus Q1. So what is your P1 now? So the given matrix is 3, 11, 5, 2. It is here 3, 11, 5, 2. Okay, accordingly we solve it. Here. So what is the value of P1? P1 will be 2. It is 8 to 2 minus 5 minus 3 by it is your 3 by 11. Once it is 3 by 11, it is 1 minus 3 by 11. So this is your 8 by 11. And it will be 2 minus 11. 2 minus 11 by your lambda. Lambda is your 11. So lambda is your minus 11. The value of lambda is minus 11. So this is minus 9 by minus 11. So 9 by 11. So this implies my Q2 is 1 minus 9 by 11 is equal to 2 by 11. Okay. Hence the mix strategy for A and B respectively given by SA is equal to A1, A2. The value of P1 is 3 by 11, 8 by 11, 3 by 11 and it is my 8 by 11 and SB is equal to B1, B2, B3. It is here 0. Q1 is 9 by 11. It is 2 by 11 with value of the game. With value of the game V is equal to 49 by 11. 49 by 11. So this is your answer. Right? This is your answer. Now to summarize this lecture, if we have a matrix of order 2 cross n or m cross 2, then we use graphical method. Here in 2xn method, 2xn payoff matrix, we don't get any saddle point, so there is no pure strategy. Also, this is not further dominated by using the dominance rule. So what we did is from A's point of view, we draw the graph and find the maximum point, and the maximum point is the intersection of here B2 and B3. So B1 is dominated. Now the reduced 2x2 matrix is solved by the process of the mixed strategy. Okay. In the next lecture, I will discuss the M×2 case. Right. So here my appeal to all of you is that if you feel this lecture is interesting to you, then you please like and subscribe to this channel. Like and subscribe to this channel. Right. So this will boost my motivation and which will help me to upload the subsequent videos for your benefit. So in my upcoming lecture, I will discuss the case of M×2 payoff matrix. Okay, M×2. Suppose this is a matrix, and here there are two strategies for B2, but for A we have A1, A2, and so on AM. So it is a M×2 matrix. Okay, so M×2 matrix, and we will see here in the subsequent lecture we will see the details of the discussions. Okay, so let us now close this lecture. Thank you all. Have a nice day.